Okay, so we're on the roof now. We're looking at two of the systems we've talked about already. The first one we'll start with is the extract ventilation system from all the flats. So this, what we've got behind me here, is the square box. There is the common extract fan that's then pulling all the air out of the flats. So you can see the ductwork coming round to that, which is basically pulling out of those risers that we looked at earlier on, where the ductwork's coming up to the roof. So that's what we've got at the top here, where the air's coming up into this duct, and then round, joining in all the other ones onto the extract fan and away. So that's fan is speed control then, depending on the demand within the system, within the flats, for the amount of extract air that's required from the individual properties. So the other system we then want to talk about then is the smoke ventilation system. So in the background is the two large cylinders over there is the smoke ventilation fans as part of the smoke ventilation system. So those are the extract fans pulling out of the corridors that we were looking at earlier on, out of the louvers. And what we've got to the side here is the inlet side. So the block there with the louvers on the top are the air inlets for that system to balance up what's being extracted out. So the fresh air is coming in there, and that's being extracted out using the extract fans over on the far side.
The building is equipped with solar panels as part of its green profile. The panels essentially collect sunlight, convert that into DC electricity, that's exported to an inverter locally, that then transfers to AC, and the AC then feeds into the building network. There's no real maintenance other than cleaning, and it's just a warm soapy water, but really you should leave it, and once a year when the PV guy comes in and checks the inverters, which are downstairs, and checks these units, he will then clean them. There's really nothing for the general day-to-day maintenance of the building. The energy produced by these panels is imported into the local network and feeds into the LV panel board, which we've discussed earlier.
Okay, I'm Gavin from South Facing, just running you through the solar panel system that you've got on this property. We've got 19 250 watt PV panels that generate DC electricity from daylight. The panels, as you can see, are laid out to catch the sun as it progresses across the sky during the day. These panels are in series and they generate DC electricity that's built up to a higher voltage and then taken across on the cables back to the inverter over there. The basics of a solar panel system that generates electricity is the panels generate DC electricity that's taken to an inverter that converts that from DC to mains AC electricity, synchronises it with the grid and feeds that back into the building's system. The building will then take power from the roof and feed that into the local distribution board, and it will take additional power from the national grid. It will always prioritise the power from the roof. This is automatic. The system will start up in the morning when the sun rises and it will switch off automatically in the day. There's nothing that needs to be done to maintain or alter that system, and the building will automatically take the power that it needs based on the amount that's being generated and the demand. The framework, the panels are fixed down on a framework to the slabs. Again, no maintenance is required beyond an annual visual inspection, probably best undertaken in the spring after the winter storms, just to check that nothing's been moved or damaged during that time. The panels also benefit from an annual clean, just as you would with windows. Again, probably best in the spring to try and maintain the best performance from the panels over the years. Other than that, there's no need to undertake any maintenance on the system. The inverter is located on this system over by the staircase. It automatically synchronises with the grid and will switch off if there's any problem with the grid or the DC power. Under normal operating conditions, it'll have a green light on here indicating power, and there'll be a reading across here just indicating what's being generated. At the moment, it's in a fault position because there's no grid supply from it, which either means that it's been switched off or the grid is down. So in this situation, we can assume that the isolator is off. Okay, so this is the connection point for the PV system. The AC power coming from the inverter comes down through this isolator through this generation meter and into this board, and feeds the bus bar within there, as well as obviously the grid. If the system needs to be switched off for any reason, precaution or any concerns, this is the point of emergency switching, and if you turn this off, the inverter will notice a lack of grid and switch off. It's worth remembering that the solar panels do remain live, potentially live during daylight, but the system is designed so everything has touch-proof connectors and shouldn't be touched except by a competent trained engineer. So if it needs to be switched off, this is the point. If the client decides to get paid through the feed-in tariff scheme, the Ofgem will want meter readings from what we call the generation meter, and that is located there. That is a way of recovering that money and being paid a tariff through the government's feed-in tariff scheme.
Carrying on from the entertainment system we discussed both within the flat and within the risers, up here mounted on the roof we've got 2 satellite dishes, an FM aerial and a terrestrial aerial. So the 2 satellite dishes allow us to have the Sky Plus facility. The terrestrial aerial allows us to have the Freeview facility, and the FM aerial is for those diehards who still have an FM set. The terrestrial aerial is pointed towards the Crystal Palace transmitter, which is the best transmitter in the area. The dishes are lined up on whichever Euro satellite we selected. They will cover the European satellite network that Sky uses in Northern Europe. Really, there's not a lot more to say. There's no maintenance out here. There's no real reason for anyone to come out here. Nothing serviceable. The only reason would be some sort of mechanical failure, and then the aerial company would come and deal with that.